Hello and welcome. In this lecture, we are going to be hooking into the play and stop events of the playable director so that when we walk into our trigger, we get a disable control log message showing up. And when we get to the end of the timeline, which is just going to happen after we see this guard, we then get a re-enable control log message. So we're getting events coming through at the right time. We're going to learn a little bit about what C# events are and also how we can use them to implement the observer pattern. So we're going to learn about the observer pattern and a little bit about C# events so that we can implement it. So let's dive right in. So as Rick pointed out last lecture, we have an issue where if I go into the cinematics, you can see I'm still able to control the character and get him into all sorts of trouble while I'm holding my mouse down. There's my character. He was running all the time and got himself into trouble. So we want to be able to remove that control. The way we're going to do this is to add a new component to the intro sequence game objects. That's under cinematics intro sequence. And we're going to want to add a new component here called the cinematic control remover. And the job of this component is that when the cinematic sequence is running, it is going to remove the control from the player. I'm going to go ahead and create it in Visual Studio Code, and I'm going to create a new file. It's going to be the cinematics control remover.cs. So go ahead and create that. I'm going to add a mono behavior in here, and I'm going to wrap this in a namespace, like if I can do it properly, like so. It's going to be RPG cinematics like we've had before. Boom. Now, in order for this component to do its job properly, it's going to need to run code when it needs to enable control and when it needs to disable control, which is going to happen when we're starting the sequence and stopping the sequence. So we've got two cases where we need a method in this script. One case is going to be when we want to disable control. At that point, we're going to want to do something in this function. And the other time is when we want to re-enable control. And the stuff that goes on in here, we could easily figure out how to do. It involves the player controller, involves cancelling actions, and so on and so forth. But how are we going to get these functions called in the first place? When are they going to be called? How can we work that out? Well, disable control, you might say, okay, easy enough. When we call the trigger and we start play on the playable director, we could call disable control. Sure, but how do we re-enable control? How do we know when the cinematic has finished? And in actual fact, knowing when the cinematic has finished, we can then do an even cleaner solution for disable control. And the thing here is that we want to be notified of a given event. And I'm going to put a start method in here because we're going to need this in a bit. So imagine we have a situation like this one. We've got a playable director and it wants to notify the control remover, maybe a particle effect, maybe some music changer. It wants to notify some things of the fact that the playable has finished playing. The timeline in our instance has finished playing. Now, the playable director can't make direct method calls to these different components because Unity, when they coded the playable director, didn't know that you might need these components. So they can't have had a direct method call to them. So we have to have some other way of telling the playable director that we'd like to know that the timeline has finished playing. Now, typically what we've seen, for example, in things like the cinematic trigger, is that if you want some code to run when a Collider's on-trigger enter event happens, then you can just use a special method name and it will automatically be called by Unity. That's one way of doing it, but it's a bit of a messy way because you need to use the exact right method name, and it can get a bit messy in terms of you have to have your component on the right game object, and it's just not as flexible and it's not as clear and straightforward. And it's especially obvious when you have things like our fighter with our hit event, right? We've even had to annotate this as being an animation event because it's so unclear who is calling this, because it's just being called because of a special name. That's so unobvious and not very nice. So there is a nicer way of doing this in C#, and that is to use events to essentially implement the observer pattern. What is the observer pattern? Well, basically, instead of the playable director calling down to the control remover, particle effects, music changer, all stuff that it has nothing at all to do with, really, it can just keep a list of things, of observers, things that want to observe an event happening in the playable director. In this case, the on-finish event, let's say. So what can happen is the control remover can register itself, the particle effect, the music change can all register themselves to this list. So notice the arrows are going this way round. It's another dependency inversion, if you like. And so what you end up with in this list is a list of the observers, the control remover, the particle effect, the music changer, etc. So now when the playable director decides to finish playing, boom, it calls to its observer list, and the observer list calls out to all the control removers. But notice in this process, the playable director didn't have to know who any of the observers were. It's kind of like our interfaces that we've already seen. The difference being that for interfaces, the arrow gets flipped typically between one class that's calling one other class, whereas here, with the observer pattern and events, these arrows can be flipped from one class calling to many classes. So back in our control remover class, I'm going to add some print statements to help us basically figure out when these methods are being called. So our disable control method, for example, is going to be one print statement, and I'll put a similar print statement in enable control. Now I'm going to introduce a component called a fake playable director, which is going to give us an indication of how Unity might be doing this under the hood, how it's working under the hood. You don't have to create this yourself, just follow along with the video to understand the concepts. And let's take a second, now that we've created these two, to actually go and stick them onto the intro sequence. So the fake playable director and the cinematic disabling remover component. So those both go on the intro sequence. Now I'm going to flesh out the fake playable director with a start method that is going to call to an onFinish method after having played for 3 seconds. This is going to simulate what the playable director does, which is wait until the clip has finished playing before calling the onFinished method. What do we want to do in here to notify all these cinematic control removers, etc.? Well, I'm going to write a line and then I'm going to explain it to you. So what we've got here is a C# event, and it's essentially the C# way of implementing that observer list from the slides. Don't worry about the specifics of how this is implemented and used in the playable director side, as we won't be doing that in our own code, but what we're interested in is knowing how we can add ourselves as an observer to this list. So I'm going to do this in the cinematic control remover. So I'm going to do the get component of the fake playable director, and I can access its onFinish. Notice here how the onFinish has a little lightning bolt. This is because of the keyword event. Basically, event allows us to add some protections to these kinds of variables that store functions or lists of functions in them. But don't worry about the keywords and this line too much right now, because we will have a dedicated lecture on declaring and using events and delegates in a few sections' time. So what we want to do is onFinish here. We are going to plus equals. This is basically adding ourselves as one of the observers in this observer pattern list. And then we need to put in the method that we want it to call. Now notice I'm calling enable control because it's finished. But notice that we don't want to use the round brackets because we're not calling it here in start. We're telling onFinish to call it. We're telling the playable director that it can call it. So we just need to give the name of the method. Now, one more thing, it says no overload matches action float. Now, the reason for this is because I deliberately made this action take a variable, and that means that our callback, just like, for example, your onTrigger has to take a collider, our onEnable control has to take, what was it? A float. Now, I've just done this to show you how this works. It's basically nonsense float, but it has to take some float value. And then what's it saying? Just that it wants a semicolon at the end of the line, obviously. So that's how you use them. How are they then called? Well, basically onFinish now would call to this delegate onFinish, and that's where the round brackets come back in. So basically onFinish is a variable that represents a list of different callbacks, a list of different functions that have registered themselves, and when we call onFinish, it actually calls all of the things in the list. So if I'd gone on to do onFinish disable control as well, both of these are going to get called. Let me, in fact, show you that that is an option. Let's see this. Yeah, just saying that we don't have the nonsense float again. And so, and also there's an error here because we haven't put any floats in. Let's put like 4.3 or something is the float that comes in, 4.3f. And let's actually go ahead and play and just show you that in the console we should be getting both the enable and disable control coming through. Go to the console, wait for 3 seconds, and we get enable and disable come through actually in the order that we added them. So that's kind of interesting. If we reverse the order, you might see that the order of them getting called is also changed. So it's time for your challenge to find the real events. Look in the docs or autocomplete. In this case, instead of using the fake playable director, let's use the real playable director. So I'll just show you playable director, and I think I need to include a different namespace. Yep, Unity Engine Playables in order to do this. And so I'll need to be able to find in here the real event. So you can do a dot and then autocomplete to find events. Remember that lightning bolt signals up events for you, or you can look in the docs if you're using a different editor. When does the director start playing? When does it finish playing? See if you can find events for both of those and test with print statements to see whether you're disabling control and enabling control at the right moment. So pause the video and have a go at the challenge. Okay, welcome back. So hopefully you're getting to grips a little bit with the idea of events and how they can help us with the observer pattern. So we'll do a dot and we'll look through this list for anything that has a little lightning bolt. There's a few of them. Paused, played, and stopped. Perfect. I think we want played for one. So played, and we can then do our plus equals to add one of the methods to the list of callbacks that should come through this. And what we want to do when it's played is we want to disable control, maybe slightly counterintuitively. Now there's an error there, but I'm going to come back to it in a second because the other callback we wanted was dot stopped, like so. And then we can do plus equals enable control instead. Okay. Now, what it's complaining about, if we hover over it, is it's saying no overload for disable control matches delegate action playable director. So you can see that it's changed here. The action, instead of being an action float, is an action playable director. So hopefully you realize that these methods need to take a playable director as the argument in here. And I'm just going to call this PD because we don't even use it. But basically this is saying this is the playable director that is calling us, that is calling this action. And if I do that, then hopefully you will be able to see that I can hit play. And I would expect to get our callbacks when we start playing and when we stop playing. We can safely ignore this null reference exception. It's coming from our fake playable director, which we're soon going to delete. If I go into the zone, you can see disabled control because we have gone into the trigger and the playable director has started playing. And then when it stopped, we should enable control again, and that has happened in the right print statement. So you can see how we're able to use events to hook into different moments in other classes' life cycle and understood a little bit how that's working behind the scenes. You don't have to fully understand this class. The important thing is that you know how to use these events and how to subscribe to them over here in the Cinematic Control Remover. So just to reinforce that, I'm actually going to go ahead and delete the fake playable director. That was only there to show us how the playable director might be working behind the scenes. Now, in this video, I actually forget to remove it from the object in the scene, which obviously leads to warnings. If you go and remove it, you'll get rid of those warnings. But if you see that on my screen, that's what's going on. Hopefully you're a bit more enlightened about events, and in the next lecture we're going to go ahead and make these disable and enable control things actually do something.